Hello, friends. Let's do the next question, the fifth question. Okay, now fifth question is cos inverse minus 1 by 2. Okay, so we have to find the principal value of cos inverse negative 1 by 2. Okay, now we know that cos inverse negative 1 by 2 is some angle theta. Now, and this angle theta must belong to its range, that is 0 to pi cos interval. Okay, so now when we look into the unit circle, we will see that this is 0 to pi, and the range of cos inverse will be 0 to pi. This will be the range, okay, where cos inverse exists, all its range exists. Okay, now negative 1 by 2. Now we know that cos is positive in first quadrant and cos is negative here in the second quadrant. So cos 1 by 2 negative 1 by 2 must be here. This is negative 1 by 2, and this must be the angle. Okay, it's angle for the negative 1 by 2. Okay, since it's moving in the positive direction, after pi by 2 this will be 2 pi by 3, 3 by 4, and 5 by 6, and so on up to pi. Okay, now this is the angle where its cos is negative 1 by 2. So if you see, if you reduce this angle from pi, you'll get the remaining angle. Okay, now if you notice cos is positive here, and cos will be also having a value here, a 1 by 2 here, which is 60 degree. Okay, and that will be pi by 3 radians. Okay, and this 60 degree is equal to this 60 degree here. Okay, because it's both are congruent. Okay, these both are angles are equal. Okay, so if you reduce this, and this is also pi by 3, this is also 60 degree, so this in radians this will be pi by 3. So if you reduce pi by 3 from pi, you'll get the remaining angle. Okay, so pi minus pi by 3. Okay, this is pi by 3. Okay, will give you, if you take the LCM, it will be 3 pi minus pi by 3 is equal to 2 pi by 3. Okay, so the angle will be 2 pi by 3, where cos inverse is negative 1 by 2. Okay, so you can write cos inverse negative 1 by 2 is equal to 2 pi by 3. The reason, since 2 pi by 3 belongs to the range 0 to pi. Okay, therefore 2 pi by 3 is the principal value of cos inverse negative 1 by 2. That's it, simple. Now sixth question. The sixth question is tan inverse negative 1. Okay, now you know that tan inverse negative 1 is some angle theta, and this theta must belongs to the range that is minus pi by 2 to pi by 2, open interval. Okay, now when we look into the ratio unit circle, this is minus pi by 2 and this is positive pi by 2. So this is a negative value, it's a negative 1, so it must be here, because all are negative here, all the values here are negative. Okay, and this is the area where tan inverse exists. Okay, so negative value must, you know, the tan is positive here in the first quadrant, so in the fourth quadrant it will be negative, so the negative value will be here, minus 1, which is minus pi by 4. Okay, so we can write tan inverse negative 1 equal to negative pi by 4, since negative pi by 4 belongs to the range minus pi by 2 to pi by 2, open interval. Therefore negative pi by 4 is the principal value of tan inverse negative 1. Simple. The seventh question. Okay, secant inverse 2 by root 3. So this is also again some angle theta, and that theta must belong to the range. The range of secant is 0 to pi close interval minus pi by 2, because at pi by 2 secant goes to infinity, so we reduce it, exclude that. And now when we take this again 0 to pi, this is the area where secant, the range of secant exists. You know the secant is positive here and negative here. Now since we have a positive value, it must be here. So secant is positive at some angle 30 degree. I mean this root 2 by root 3 is at some 30 degree, which is pi by 6. Okay, so we can write secant inverse of 2 by root 3 is equal to pi by 6. Since pi by 6 belongs to the range 0 to pi minus pi by 2, therefore pi by 6 is the principal value of secant inverse 2 by root 3. Okay, next eighth question. What is the eighth question? It's cot inverse root 3. Now again, you know that cot inverse root 3 is some angle theta, and that theta belongs to the range that is 0 to pi. The 0 to pi is the open interval, is the range of cot inverse. Okay, so at what value is cot inverse root 3? When we look into here in this ratio of unit cycle, this is 0 to pi. This is where cot inverse exists, the range of cot inverse exists. Since this is a positive value, and we know that cot is positive here and it's negative here, since this is a positive value, it must exist in the positive area. So this is where cot exists. It's root 3. Cot root 3 is again at some 30 degree, which is pi by 6. So you can write cot inverse root 3 is equal to pi by 6, since pi by 6 belongs to the range 0 to pi open interval. Therefore pi by 6 is the principal value. Pi by 6 is the principal value of cot inverse root 3. Okay, then ninth question. Cos inverse negative 1 by root 2. Okay, so you know that cos inverse negative 1 by root 2 is some angle theta, and that theta must belong to the range of cos inverse, that is 0 to pi, close interval. Now when we look into the ratio of the unit circle, this is 0 and this is pi. Okay, this is the area where the range of cos exists. Okay, now cos is positive here in the first quadrant, it is negative here in the second quadrant. So you see this is a negative value, so it must be here. Okay, somewhere here. So cot inverse, so we have to find this angle. So if you reduce this angle from this total angle from pi, you'll get this angle. So this is negative 1 by root 2. Okay, so you know that cos is also have a positive value of 1 by root 2. Okay, which is 45 degree. Okay, which is 45 degree, that is pi by 4 in radians. So if you reduce pi by 4, and since these both angles are equal, if you reduce this pi by 4, this is also 45. You reduce pi by 4 from pi, you'll get this angle. Okay, so pi minus pi by 4, you take LCM, it's 4 pi minus pi, which is 3 pi by 4. Okay, so this angle is 3 pi by 4. At 3 pi by 4, cos inverse is negative 1 by root 3. So cos inverse negative 1 by 2 root 2, it's 3 pi by 4. Since 3 pi by 4 belongs to the range 0 to pi, close interval. Therefore 3 pi by 4 is the principal value of cos inverse negative 1 by root 2. Okay, now 10th question. Cosecant inverse negative root 2. Now you know that cosecant inverse negative root 2 is some angle theta, and that theta must belong to the range of cosecant inverse, that is from minus pi by 2 to pi by 2, close interval, and minus 0. When you look into the ratio of the unit circle, this is minus pi by 2 to this is pi by 2. Okay, now this is 0. 0 is excluded because it goes to negative infinity. Cosecant inverse goes to infinity at 0. Okay, now this is the area where cosecant inverse exists, the range of cosecant inverse exists. Since cosecant is positive in the first quadrant and it's negative here in the fourth quadrant, so here you have negative root 2, so it must be in the fourth quadrant. Okay, negative root 2. Now we know that cosecant is cosecant 45 is root 2. Okay, so cosecant inverse root 2 is equal to negative 45 degree. It must be here, which is minus pi by 4, right? Minus pi by 4. Okay, and the reason is, since negative pi by 4 belongs to the range minus pi by 2 to pi by 2, close interval minus 0. Okay, therefore minus pi by 4 is the principal value of cosecant inverse negative root 2. It's negative root 2. Okay, it's negative root 2. Okay, that's it.